Assalamu alaikum respected students. Last time we have discussed the deviation of real gases from ideal behaviors, as well as we have explained why the real gases deviate from the ideal behaviors. The real situation which cause the deviation from ideal behavior is under the extreme condition. What is the extreme condition? It is the low temperature and high pressures. Now we will explain this deviation with respect to compressibility factors. What is the compressibility factor? Basically, compressibility factor is the ratio of PV over RT. PV is equal to RT, that is general gas equation for ideal gas for 1 mole of gas. If we explain it further, the PV, P is the pressure, Vm that is the molar volume, R is the general gas constant, T is the temperatures in Kelvin. The ratio of PV is RT is equal to Z, that is known as compressibility factor. This compressibility factor is equal to 1 for ideal gases. This compressibility factor for real gases may be greater than 1, may be less than 1, but not equal to 1. At low pressure, Z is equal to 1, meaning the gas behave nearly ideally, but not exactly ideals, near to ideal, near to 1, not exact 1. Okay, at as a pressure increase from low pressure to moderate pressures, this value of compressibility factor at the start become low, in other words, less than 1. When we increase the pressure, the value of Z increases greater than 1. With respect to temperature, at low temperatures, attraction dominant over the kinetic energy, so zip further below the 1 before rising. At high temperature, kinetic energy overcome the attraction, so deviation are smaller. We see this phenomena via graph. That is a graph in which y-axis is the compressibility factor values, that is 0, 0.1, 1, 1.5 and 2. 1 is the compressibility factor value for ideal gases, that is represented by the red line. It is for the ideal gases. Okay, compressibility factor PV over RT, if less than 1, its mean effect of interparticles attraction dominant. Okay, if PV over RT, our compressibility factor, is greater than 1, effect of particles of volume is predominant. With respect to pressure, we see this graph. At the start, carbon dioxide or methane gas at the start, when pressure increase from low to moderate, first of all compressibility factor decrease. When pressure is increases with the passage of time on the x-axis, the compressibility factor increase and greater than the 1, dominantly for the carbon dioxide and the methane gases. For the helium and hydrogens, the compressibility factor is always greater than 1. When we increase the pressures, their value of compressibility factor is increases. Okay, next, with respect to temperature, see that if the temperature is 273 Kelvin, is the 0 Celsius, at the start we take the example of 4 gases, same hydrogen, helium, hydrogen, nitrogen and carbon dioxide. We know that the heliums and hydrogen are purely non-polar gases. These non-polar gases show more ideal behavior. The polar gases, for example carbon dioxide, may have a polar natures, more polar natures, and larger in size. as compared to helium and hydrogens, they show more deviations. When temperature is 0 Celsius at the low temperatures at the start, uh, compressibility factor is equal to 1. Then if we increase the pressure from 0 to moderate, then compressibility factor decreases and less than 1 at the start. When we increase the pressure from moderate to high, their compressibility factor increases. uh, but compressibility factor of hydrogen and helium always is greater than 1 from low pressure to the high pressures. What is the reason behind this? The reason is that when at the low temperature, uh, force of attraction become dominant. When force of attraction between the gas molecules become the dominant, then gases deviate prominently from the ideal behaviors. If we increase the temperature from 0 to 100, this deviation is slightly less as compared to 0 Celsius. The reason is that when we increase the temperature, kinetic energy of the gas molecules increases. They uh, move away from each other, and force of attraction between the gas molecules become negligible, and they behave uh, like ideal gases. Not exactly ideal, near to the ideal. Most ideal behavior is related to the helium, then hydrogen, then nitrogen, then carbon dioxide. Okay. uh, I hope so you understand this concept, why gases deviate from ideal behavior when we increase the pressure, when we decrease the temperature. By increasing the pressure and by decreasing the temperature, the force of attraction between the gas molecules become dominant. When the force of attraction between the gas molecules become dominant, the force of attraction between dominant and gases deviate from ideal behavior. Hope so you understand this concept.